Philippine Mathematical Olympiad 2022 National Stage Rhythm Phrase Day 1 Problem number 324. So, for having next videos and also any hint or explanation about this exam and also other exams, SUMAC, Promise, summer camps, anything in USA, and also British Olympiad, if you wanted any hint or solution, subscribe, and wanted the new video, subscribe and turn on the bell, like the videos, and send message through my WhatsApp number here. So let's see how we can solve problem number 3. It says call a lattice point visible if the line segment connecting the point and the origin doesn't pass through another lattice point. Given a positive integer k denoted by sk, the set of all visible lattice points xy such that x squared plus y squared equals k squared. So sk, k squared. It is a circle with radius k and center origin. Let D denote the set of all positive divisors of 2021 times 2025. Compute the sum. Sigma D belongs to big D, and the number of SD here, a lattice point, is a point xy on the plane where both x and y are integers, and this denotes the number of elements of the set A. 2021, if we prime factorize, it would be 43 times 47, and 2025 is 25 times 81. Now, before solving this problem, we want to work on a famous lemma. The lemma says what? If P is a prime number, prime, and it's 4k plus 3. It is congruent to 3 mod 4, and P divides A squared plus B squared, then P divides A and P divides B. Proof of this lemma, assume on contrary that P doesn't divide A. So because P divides A squared plus B squared, so P also doesn't divide P. Because if P divides one of them, for example, if P divides A, then P divides A squared, and because P divides A squared plus B squared, then P divides B squared. If you subtract, then you can conclude P divides B. So if P doesn't divide A, then P doesn't divide B. Now we know P divides A squared plus B squared, so A squared is congruent to negative B squared mod B. If you raise both sides to the power of P minus 1 over 2, so it would be this. Since P is congruent to 3 mod 4, P minus 1 over 2 is odd. Now we can say because it is odd, then we have negative. Negative remains. So it would be A to the power of P minus 1, negative B to the power of P minus 1. By Fermat's leader theorem, we know A to the power of P minus 1 is 1, and here is negative 1, so mod P. And so we can say P divides 1 minus minus 1, P divides 2, and it's a contradiction. Now we use this lemma. So let's consider that we have a point, and if we want to say that this is lattice, this point is visible, the name was visible. If this lattice point is visible, then let's see what condition it should have. So if we have AB here and CD here, so this length is CD, this length is B, C and A. By Thayer's theorem, we can say C over A equals D over B. So we can change it to C over D, take D here, and A here, A over B. So if A over B is in lowest term, we should visible, when we have visible point, we shouldn't have point inside this line segment. So when you can simplify A over B, you would reach a smaller fraction. In, for example, numerator would be smaller and denominator would be smaller, so you can simplify A over B. And if A over B is in lowest term, then you can say A and AB is visible. So AB is visible if G is, it means what in lowest term? GCD of A and B should be 1. Now, suppose that A squared plus B squared equals K squared. Now, if P is congruent to 3 mod 4 and P divides K, then by our lemma, we can say P divides A, P divides B, and that's a contradiction. Because we proved that a visible point, the GCD of A and B should be equal to 1. Now here, it's a contradiction that their GCD P divides their GCD. So because of this important and useful conclusion here, we can say, okay, if we consider prime factors, Because 43 is a prime factor and it's congruent to 3 mod 4, we can't use that. Also, we can't use that here. 81 is 3 to the power of 4, so 3 is a bad prime. So the only divisors that we should consider, divisors of 21. So S1, S5, S25. For S1, a squared plus b squared equals 1. So all these four numbers are good. Four numbers, you can check these four numbers. So here when we have 0, if the, for example, radius is greater than this, for example, greater than equal to, then we have another point, so it is not visible. So these 4 points, when one of the coordinates equals 0, then only for 0, 1, and the next one must be 1 or -1. So here we have 4 good points. Now S5. It means a squared plus b squared equals 5 squared 25. The only answers are plus -4, plus -3, and you can switch. So here two times because of plus minus, 2 times plus minus, and 2 times because 4 3 or 3 4. So 2 2 2 would be 8. And also if you say okay 5 0, it is not good, because if you consider 5 0, then between these two numbers, we have, for example, 1, 0, and also 4 other points. So 5, 0 is not good. Now, the last one. Here we have 8 good points, 4 good points, 4 visible points, 8 visible points. The last case we should consider S25, which a squared plus b squared equals 25 squared, which equals 625. So let's consider this. We write all the squares less than or equal 6 to 5, and then we should try that sum of which of them equals 6 to 5. So if you check 6 to 5 can be equal to 576 plus 49, or 400 plus 2 to 5, which equals 24 squared plus 7 squared equals 20 squared plus 15 squared. Because we said their GCD must be 1, so 20 over 15 is not the lowest term, so it is bad. We should consider only 24 and 7. So plus minus 24 plus minus 7, so 2 times plus minus, 2 times plus minus, and you can switch 24 7 or 7 24, 2 2 2 8. So the answer would be 4 plus 8 plus again 8 8 8 16, and 4 20.